All right, let's talk about Python. Today we're going on a little journey. We're going to take your Python code from just a simple script that runs once and forgets everything and turn it into a real-world application, one that can remember things, communicate with other systems, and survive out in the wild. Let's jump in.
You know that feeling, right? You write this really cool script, maybe a to-do list or something, and it works great. But then you close it, and everything you did is gone. Poof! Vanished. That's because it was all living in what's called volatile memory, a temporary workspace that gets totally wiped clean. Your code is effectively trapped, and today, we're going to set it free.
So this is the leap we're making today. We're going from the left side, a fragile script that forgets everything and crashes at the first sign of trouble, to the right side, a real application with a persistent memory, one that can handle errors without even breaking a sweat.
Okay, so first things first. If we want our program to stop being so forgetful, we have to give it a long-term memory. And the most basic, fundamental way to do that is to teach it how to read and write files right on your computer.
The key to this whole superpower is one single powerful function, open. You can think of it like the gatekeeper to your computer's hard drive. You just tell it which file you want to access and what you plan to do, and it opens the door for you.
Now, that what you plan to do part is called the mode. You can use R just to read a file. But the two you really have to pay attention to are W for write, which will completely erase and overwrite a file, and A for append, which just tacks new information onto the end. Getting this right is absolutely crucial.
Now, for the longest time, this is how you'd do it. You'd open a file, do whatever you needed to do, and then, and this is the important part, you had to remember to manually close it. But what if you forgot? Or what if your program crashed halfway through? Yeah, you could end up with a locked file or even lose data. Not great.
And that's why this is the modern, cleaner, and way safer method. When you use the with statement, you're basically telling Python, hey, you handle this for me. As soon as your code in that block is done, Python automatically guarantees the file gets closed properly no matter what happens. It's like having an automatic cleanup crew for your files. Okay, awesome. Our program can now remember things by saving them to a file. That is a huge step. But, in the real world, data isn't just some big blob of text. It has structure. So now, we need to teach our program how to speak the universal languages of data. Think about it like this. A plain text file is like a story with no punctuation, no paragraphs, no chapters. It's just a wall of text that's really hard to follow. But structured data, like CSV or JSON, provides that organization. It has rules, which makes it incredibly easy for our program to read and understand what's what. So first up, we have CSV, which stands for comma-separated values. And really, it's just like a simple spreadsheet. Each line is a new row, and commas are used to separate the columns. It's absolutely perfect for any kind of tabular data, and Python has a built-in CSV library that makes working with it super easy.
And then there's JSON. This one is huge. It uses key value pairs, which is fantastic for more complex or nested information. I mean, if you've ever pulled data from a website using an API, or even looked at a modern configuration file, you have almost certainly seen JSON. It's basically the language of the modern web, and Python handles it beautifully.
Our application is coming along nicely. It can remember things, and it can communicate. But what happens when things go wrong? What if a file it needs just doesn't exist? A fragile script would just crash and burn. A resilient application is prepared. So it's time to give our program some armor.
We've all seen it. You run your code, everything seems fine, and then, bam! A screen full of red error text stops everything dead in its tracks. Errors like file not found error are just going to happen. That's a fact of life in programming. The difference is a real application expects them and knows exactly what to do when they pop up. The tool we use for this is the try except block. Here's the game plan. You put your risky code, the stuff that might fail, inside the try block. If an error happens, the program doesn't crash. Instead, it jumps to the except block, where you can handle the problem gracefully. You can even add an else block for code that only runs on success and a finally block for any cleanup that must run no matter what. This gives you complete control.
So let's pull all this together and take a look at what we've accomplished. We started with a simple, forgetful script, but by adding just these three core concepts, we have fundamentally upgraded its capabilities. Let's see what our program can do now.
So check it out. Your program now has a memory, thanks to file handling. It can communicate effectively using structured data like CSV and JSON.
And most importantly, it's now resilient. It can face unexpected problems and recover using exception handling. It's not just a script anymore, it's a proper application.
By mastering these fundamentals, you've really unlocked the ability to build things that are truly useful, tools that persist, interact, and don't fall over at the first sign of trouble. So the only question left is, with these new powers, what are you going to build first?